Welcome to a new video on my channel. This is Python Basics for Machine Learning. In today's episode we are gonna have a look at pandas. Not the animal panda, but the Python library panda, and why we should care as machine learning practitioners about this library. But before we dive into pandas, make sure that you have watched my video on NumPy before proceeding, because we will build on top of it, since pandas is heavily relying on NumPy. So let's go. What is pandas? Pandas says the following about itself on the official GitHub page. Pandas is a Python package that provides fast, flexible, and expressive data structures designed to make working with relational and or labeled data both easy and intuitive. Well, in machine learning we are often working with labeled and relational data, so pandas might turn out to be very useful. But before we dive into the code, let's have a look at pandas series and data frames first. The pandas documentation says that series is a one-dimensional labeled array capable of holding any data type, and so forth. So the series object is a data structure that is very similar to an array that supports index labeling. We would initialize a series object in this way. We would give as an input our data and also an index. Let's go over a few examples. In the first example, we are having a list of numbers as data and a list of strings as labels. When we have a look at our series object, we would see the following output. You can see that every index is labeled and each index label is associated with an item of our list. In the second example, we still provide our data, but this time the index is equal to none. As we can see, the pandas series object has numbers as indices that are incrementing. Our data is still the same. Of course, pandas would be pretty boring if we would only have a little bit more fancy arrays, right? This is why pandas has also implemented a data structure called DataFrame. The pandas documentation says that DataFrame is a two-dimensional labeled data structure with columns of potentially different types. We will see that data frames are similar to spreadsheets or tables, similar to tables in relational databases. Let's get our first example, where we use the DataFrame class in order to initialize our data frame. Our input is a dictionary with two columns, named col1 and col2. Each column value is a pandas series object with some data in it. I've written the structure of this data frame down below, where we can see that our columns are labeled, and we also have indices on the left-hand side starting from 0 onwards. Each column has data in it, the data that we have defined. Of course, we can use other data structures in order to initialize data frames. We will not cover all possible ways since there are so many, but this is a common one where we give NumPy arrays as input via a dictionary again. The structure is the same since the labels and the data are the same. Actually, we didn't specify yet the first argument of the data frame explicitly, but it is named data. And we can also pass an index argument that will change the index labels. As we can see, since the column labels and data are the same, the only thing that has changed are the indices. Finally, before you dive straight into pandas and try to load large data volumes, I have to mention one caveat. Although there are tricks to make pandas work on very large data sets, although with restrictions, you should opt out for other libraries frameworks like Spark or Dask. In this case, since pandas is using in-memory data structures, so data structures that live in the main memory of your computer. For a larger dataset, you will need to utilize distributed computing in order to tackle data volumes that cannot be stored on any conventional computer. So without talking too much, let's dive into the code and explore some characteristics and cool features. So let's have a look at pandas in our code. So I've prepared some code here which will show the main characteristic of pandas. Of course, we will not, or I cannot show you the whole library. Pandas is a very large library as well as NumPy is. So take your time, go through the documentation, read through the most important functions, and try to implement something yourself and try to feel like how it is to handle pandas. But here I will give you a short introduction. So the first thing which we'll have to have a look at is how you can load CSV data into a panda data frame. And pandas has a method which is called read CSV, and this function allows you to specify a path to a CSV file and it will try to parse the CSV file and give it back as a data frame. Of course, if you hover over this function, you can see there are a lot of optional arguments which you can pass to read CSV, like the separator and delimiter and the header and so on, because not every CSV file has the same delimiter, for example, or separator. And if you have some custom CSV file with a different kind of separator or delimiter, different from the default, let's say, then you can pass it as arguments here. In this case, we have a pretty standard CSV where our delimiter is just a comma, and we can just load it, and then we get a data frame back, and every data frame has a function on it which you can call, which is called head, and head allows us to pass as an argument the number of rows which we want to have a look at. So if I run the script, and here it goes. So that is just some dummy data I generated where we have an ID column, a name column, a job, the salary per year, and the department. And I have the same as a JSON, because we are not only able to read CSV files, we are also able to read JSON, and pandas has a lot more options of different kind of files that you can read. And here again, the function is pretty similar to read CSV. We can pass the path to a JSON file as an argument, and we can call head. This time I will pass n equal to 2 in order to show you that we only get back 2 rows instead of all of them, right? Because now our data set has only 5 rows, and here we have put n equal to 10, so it will only show the rows that are available, right? Up until 10 rows. In this case, we have only 5. So if we run the script again, as you can see, now we only get 2 rows to see. Of course, what you can also do in pandas, you can create deep copies or shallow copies. What are shallow copies? Essentially, when you have a shallow copy and you change the data frame from the shallow copy, then also the data frame that you have copied from will also change. And if we don't want that to happen, we can do a deep copy. So when we change this new data frame, then df.json will not get overwritten. So it will stay unchanged. What we can also do is we can have a look at the columns, because every data frame has an attribute columns. And when we have a look, we can see our columns are ID, name, job, salary per year, department. What we can also do is we can have a look at the data types. And we can see name, job, and department that are strings. And that's why we have object here. And ID and salary per year are given as integers. We can also print a little summary with the info function on our data frame. And what it will give back, as we can see, we get here the info summary of the data frame. We will get the class that is a data frame. We get that it has only 5 entries. The index goes from 0 to 4. We have 5 columns, and the columns are listed. It's showing how many non-null count values we have in each column, and also which data type. So sometimes pretty convenient. And also what we get is the memory usage. So in this case, 328 bytes. So not that bad. You can also have a look at the memory consumption with a different kind of function, which is called memory usage. And we can pass different kind of arguments in order to specify what kind of information we want to have. When you scroll down here in the parameters, we can see when index is set to false, it specifies whether to include the memory usage of a data frame index in the return series. And if the index is true, the memory usage of the index is the first item in the output. And if deep is equal to true, which is also set in our case, then introspect the data deeply by interrogating object dtypes for system level memory consumptions. In this case, we know we have object dtypes, right? So that's why we have set it to true. And when we execute it, we get a small little summary or a breakdown of the memory consumption of the data frame, and we can see how much the ID is consuming, the name, the job, and so on. What we can also print is the size and the shape of a data frame. So in this case, we get a size of 25. Why 25? Because we have 5 rows, we have 5 columns, 5 times 5, 25, right? And the shape is 5 times 5 because we have 5 indices and 5 columns. And we can also, of course, access the rows through the function iloc, which, as is written here, is a purely integer location-based indexing for selection by position. So in this case, we put in a 1. This is 0-based index, so we will retrieve the second row. When we print it out, you can see that here the access by index is indeed the second entry. And we can also give a mask to it. So say we want only up to the third row. So the first and the second row. This is here the result. Then we can also specify multiple indices which we want to retrieve. In this case, the second and third element. This is that here. And we can also pass a lambda function as a mask. And in this case, we want to have every row where the index modulo 3 is equal to 0. You can do all kinds of different stuff with that. And you can also access by labels. Suppose you have a data frame, and this data frame has indices yes and no. So this time we don't have numbers as indices, but really strings. And we also give our columns some labels, hello and world. And what we can say is, if we use the loc function now, we can specify the label. In this case, for example, we would like to retrieve the index no. And when we do that, what we should get back is C and D, right? Because that's this is the first row here, and that's the second row. And we are asking for the second index. With the insert method, we can insert new values into our data frame. In this case, we want to insert a new column all around V, and we also pass the values. So when we do that, we can see that our columns are now hello all around the world with the indices yes and no and the new values E and F. Then there's another thing which is kinda handy from time to time, and this is the where clause. So when you have a data frame, you can use the where function with a specified condition. And when we have a look at this, it will replace values where the condition is not fulfilled, essentially. So when we have a look here, so this is the result, we can see. So our condition is that, so we have put in that the data frame 2, which we are referencing here, should be equal to A. And the only element that is equal to A is the first one. And this is why we get this element back, and we specified other as Z. So all the other values where this condition is not true will be replaced with Z. And this is what we see here. And there's also a very similar function which is called mask. We can also pass a condition to it, and what will happen is that when the condition is true, it will mask the value. So in this case, A is the only one which fulfills the condition, and that is why it's substituted with a none value. You can also drop duplicates. So we have specified here another data frame with some none values. And what you can do is you can use the function drop duplicates. And we say in place to true, so that we don't get back a new data frame, but we change the values in place in our data frame reference. And when we print it out, what we'll see is, so when we have a look at our data frame, we have some none values here. And when we drop the duplicates, we can see that the index 2 and 3, so the rows which are associated to index 2 and 3 are the same, right? And this is why one of them gets dropped. Of course, what you can also do, you can do computations. You can, for example, use the mean and median function in order to compute the mean or median of the individual columns. But you can also pass an axis as an argument if you don't want to do it column-wise, but for example row-wise. We have a look. We can see that we get for the different columns A, B, C, the mean values or the median values. Also very convenient. We can also check for nonce. We know that we have nonce, and what we will get is like a condition mask where when the value was none, it will return false. And if we have none values, it will get true. This is pretty handy for detecting none values in a pandas data frame. And we can also do counting. So counting means that each value that is not equal to none will be counted. So when we have a look at A, we have 1, 2, 3, 4, 5 values, but we have only 4. Why is that? Well, because we dropped a duplicate, right? So we have one row less. So we have only 4 values that are not none. For B, it's then 3 values, and for C, it's again 4 values. And we can also replace none values. So there's a method fillna, and we can pass a value. For example, in this case, we pass the median of each column, and we fill each of the values which are missing with the median of the column. Yeah, you can see that the median of the columns are substituted in for the none value. This is pretty handy for imputations. And we can also sample, of course, from a data frame. So for example, this is a little bit more complicated. So now what we do is we sample. So we sample from our df3, and we can pass as an argument the fraction parameter, which tells us how many samples we want to retrieve. We say that we want to do the sampling with replacement, and we give and we also pass as an argument the random state, which is essentially a seed value. What we can then do, for example, is we can, when we did the sampling, we can also combine it with other methods. We can chain them together. So we can say, okay, we want to fill all NA values with the medians, but we want to sample from that result with a fraction of 0.5, and we want to reset the indices. So when we do that, what you can observe is that before we had 5 rows. We had 5 rows, and we are sampling from that with a fraction of 0.5, which is due to rounding 2 rows. And we are resetting the index, so the index is going from 0 to 1. And as we can see, we sampled this row here and that row here. We can also do group bys. This is something you maybe know from SQL, where you have in here it's pretty similar. You have a data frame, you tell your data frame when you call a group by which column should be grouped, in this case department, and when we select a column, in this case salary per year, and we want to assess the rank. And what we can then do is we just construct a new data frame where we append this result which we got from the rank. So when we run our script, we can see that now we have the name and the department and the salary per year, because we also selected it here, right? And here we appended the name and department. And here with the salary per year, we can see the rank for each department for the salary. And a very important question is how to iterate over data frames. And usually one has to say that this is an anti-pattern. At least a few of these methods on how to iterate over a data frame you should not use, or at least only use it when you know what you're doing, or when there's no other way in order to achieve a certain goal that you want. So in this case, we have a very plain iteration. What we just do is we call the items method, and what it does is it iterates over column name series pairs. So we have here the index, we have here the content of the row, and what we're doing is we're just printing it. So let's do it. Just demonstrating, and now you can see here we get the indices, and the content is in this case, for example, the department, where we have a different kind of departments, the salary per years, the names, the IDs, and so on. And this is one way on how you can iterate over a data frame. But what you should do, or what you also shouldn't do, is there's also this apply method. What does apply does? So apply allows you to apply a function along an axis of a data frame. So we can pass, for example, a lambda function in here. For example, in this lambda function, we take each row and we compute the standard deviation for each row with a degree of freedoms equal to 1. And actually, you should never use that apply, except when I said, except you know what you're doing, or when there's no other way to achieve the result you want to have. And I will demonstrate to you why it's a bad idea to use apply when you have a large data set. So for example, here we artificially generate some data set, which is very large. And we will compare that with vectorization. Because for example, pandas offers a lot of functions which are efficiently implemented. And in this case, it's the standard deviation function, also with a degree of freedom equal to 1. We will see that the result will be the same. But we'll see that the time each of them needs will differ. And as you can see here, we get the same result. It's approximately 1. Okay, it's also no wonder that it's 1 because we are sampling from a Gaussian distribution and from a standard normal distribution. And we know the standard normal distribution has a variance of 1. So that's good to see that we are almost there. And as we can see, the apply took approximately 2.5 seconds. And with vectorization, it took only 2.15 seconds. So this doesn't seem like a very large difference, but if you have a very, very large data set, larger than that, and also with different kind of columns, let's say like 50 columns with different kind of data types, and you iterate over that with apply and do some computations on your data frame, it can take really a few minutes or half an hour, depending on the size of your data frame. And when you do vectorization, you are much faster. So we are talking about a factor in the order of 10. Yeah, totally depends on the computation and so on. But when you have a look at benchmarks that user published online, then you will see that vectorization always beats apply when you deal with larger data sets. And in machine learning, we are always dealing with large data sets. So it always makes sense to think about another method than using apply or this iteration technique. And also, any method that contains iter in its name, you should only use in exceptional cases. I hope you found this video insightful and helpful. Please like and subscribe, and if you have ideas for other videos that are interesting to you, write them down below in the comments. Thank you, and see you in the next time.